Hi, my name is Abby Brown, and I teach at Turbines High School in San Diego, California. My presentation is 3D printing in high school with Mathematica. I will be sharing my early experiences using 3D printers, even as an experienced Mathematica user.
Well, hi everyone. My name is Abby Brown, and I teach at Turbines High School in San Diego, California. And it's always good to be back to the Wolfram Technology Conference. I like enjoying seeing familiar faces as well as new faces. Typically, when I've been doing presentations here in the past, it's been me introducing my students. I have some students here this year, but they're going to be presenting in the next talk at 1:30 with Eric Nelson about project work they've done through Augment software. This year I get to present about a project that I've been doing for the past few months, and that is 3D printing. So I've been working with Mathematica since the mid-1990s and have been including Mathematica in my teaching for about 20 years. But I'm much newer to the world of 3D printing. It's something that's been in the back of my mind for a long time. And just last school year, my school received 2 3D printers through a grant for our career technical education program, in particular our CAD classes that we have. But once I learned there were 3D printers on campus, I knew I had to get my hands on them. And in fact, the first people to get their hands on it were a couple of my students who were also taking the CAD class. And the CAD teacher didn't know how to use them either. So we kind of turned it over to the students who figured out how to use the printers. And then they, in turn, taught me and my colleague, Mr. John Tater. So today I'm going to share with you a couple of my favorite stories from the early days of printing, along with several of the different strategies I've used with some of the challenges and things that I've come across through them. And I'm going to share a couple of projects done by my students and wrap it up with some additional concluding thoughts. For anybody unfamiliar with 3D printing and its process, there's actually kind of 3 steps that go along with it. I use Mathematica to create models, which then get exported to STL files. And then I use another program. We use Simplify 3D, but there's several different programs out there that interprets the STL file and lets us figure out the support material and the exact information to talk to the printer so that it can produce the model in the end. And it exports that as G code, which is then interpreted by the 3D printer. So a lot of times when I'm showing this they think I can just plug in Mathematica to the printer and just hit print and go, but it's much more complicated than that, as anybody who's been involved with 3D printing knows. So one of my favorite stories actually comes from my first day of 3D printing. So the students showed me some things. I went home and I printed something, and I was so excited, and I brought it to lunch that day because I got it printed that first thing in the morning. And I showed it to a few of the other math teachers. And one of the other calculus teachers just lit up, and he said, I've always wanted models for these calculus problems, in particular number 61 and this worksheet that I do. And then it's these solids of known cross-sections. So he emails this to me immediately after lunch. And I'm like, solids of known cross-sections. I know I did some code for that a while ago. And I went to my AbbeyMath website, and I found code that I had written 15 years ago. And it still works in Mathematica. And all I had to do was change the equations to match the problem, and I produced my model. And then I got to use this printout 3D function that I had heard about in Mathematica. And the next morning, I set it up to print. And by lunchtime the next school day, I had the model in hand for my colleague. So it was 24 hours later, even with only 1 day of printing experience, using that 15-year-old Mathematica code and the power of Printout 3D, I was able to create a model. And shortly thereafter, I was anticipating a lesson in my multivariable calculus class where we figure out the maximum, minimum, and saddle points of a surface. In fact, I'm teaching this on Monday. And this is what it looks like when I teach the lesson, or we do an example. So I have this big example, we go through it all, and I say, we have a surface with a maximum and 3 saddles. What on earth could that look like? And we try to sketch the contour plot. And then, of course, for the last several years, I could bust out Mathematica and say, oh, here's what our surface looks like. Here's the contour plot. And then last spring, when I was just learning how to do the 3D printing, I said, I can do more. And so I took the surface, set it up with the printing, and was able to then reveal the surface to the class, and the students could have it in hand. So now they have the opportunity to actually feel and understand really what does a saddle point look like. And this is a screenshot of Simplify 3D, where you're able to view the kind of a preview of how it will print. But what was fascinating to me about this was when I looked at it from the top down, and here I just have sort of a few screenshots. I shared this with the students to help them understand the process of 3D printing that we were doing right there on campus. And immediately they recognized what they were seeing here were the contours, those level curves. Oh, yeah, if everyone's got a chance to see them. But those level curves that we were just talking about earlier in the chapter, and again with this same problem. And so here we have this real-world hands-on application of these multivariable concepts that we've been working through. So what are some of the strategies that I've been using to create 3D models? So this I created, I've wanted one for 20 years, a little thing to help me demonstrate how curl works. And I wanted to bring it, but I wasn't sure I was going to get that through airport security. It's about 8 inches long. So I decided it wasn't worth the risk, and I left it at home. You could build something like this in Graphics 3D very easily. You don't need much code for that. But what I was finding that when I would export to STL in Mathematica, elements might be missing. So here the ball was just missing. So I changed it to sphere, and it shows up. But then when I preview prints, I would notice there's a lot of gaps. And so those gaps matter. The printer would actually not print something there, and then things would become unstable or break apart. And I have other examples where primitives I would want them like interlocking, and they would fill in very weird ways, and I could tell that even if I tried printing it, the whole thing would fall apart. So Graphics 3D also can't control the resolution, and I really like nice, smooth surfaces. And so I've learned that these details print. So even though these, at a glance it's a sphere and a cylinder, all of those individual polygons would actually show with the high resolution that the printer can attain. So region plot 3D is kind of another way I've been trying to explore things, in particular because I can control the plot points and up the resolution. But this has a huge issue with calculation time and file size. So just preparing this talk, I ran this with different levels of plot points, and it took 42 minutes to get this one at 100. I tried running 300 plot points, what I had originally printed it at, and after my computer running a whole day of school, I just killed it. So it took several hours and it didn't even finish. So that can be very impractical when you're trying to create models and edit things. Even in preparing this talk, switching from 11.1 to 11.2, I learned that some things were different. Region Union used to accept a list for Region Union, and I could easily create, this is with Graphics 3D. And so it's easy to create something like this. And then Region Union worked the same way, and I could just accept the list. But then in 11.2, I found I couldn't do that. I was getting errors, and I learned that I had to not have a list. So I had to apply Region Union to my list, which isn't that big of a deal, but I'm starting to think about how am I going to teach my students how to do this? And so if they have to take that extra leap in logic when they're just learning Mathematica in the first place, this is the kind of something that's going to create stumbling blocks for them. Likewise, rotate. Rotate in graphics, piece of cake. It's no problem at all. But with region plot 3D, I have to do a transformed region and a rotation transform. Again, once I figured that out, it wasn't too hard to deal with. But again, I'm thinking in terms of sharing this with lots of students, and it's just going to be a little bit more of a complication. So region plot 3D is certainly not as intuitive as graphics 3D, but I'm also still learning some of the tricks of working with that. I know that there's all these regions and meshes in Mathematica, and This is something that I've really just kind of worked with a little bit, and I know it's a big area also leading toward 3D printing. I did try some things in this, and I tried like repair mesh, but I couldn't get anything to repair. It wasn't working, but maybe that's better now. I still have issues with resolution. It still doesn't get as smooth. This was the smoothest I could get, and this is supposed to be like a squared off corner here, not rounded like this. So a whole nother approach to creating prints. I got inspired with trying to figure out how to take images into 3D prints, and I followed along with the guide page on the Wolfram Language Gallery on how to make a 3D image from an elevation map. And having flown over Mount St. Helens many times in my life as my family travels from San Diego to Spokane, I wanted to try to print it. So just using the guide page and entities here, I pulled up the county that includes Mount St. Helens, took that section, this was in the guide page, so I did it too, and then I made a list plot 3D, and then applied the plot theme filled surface. So the next thing I knew is I had Mount St. Helens ready to print. And sure enough, I did, and I was able to, we were able to do this. In fact, I'm just sharing this little bit of code with another student for a final project. She picked another mountain and was looking at gradients and all sorts of things, and was able to reproduce her own 3D print similar. One thing about printing with this style is that the resolution is only as good as the original image. I had to estimate what I thought the appropriate height would be, because the blacks and the whites were going from just 0 to 1, and all of the pixels were the X and Y axes. So it was like a pixel number. So it wasn't in like kilometers or something that was relevant to the image. And then I was messing around with a picture of my kids, and I was hoping this would still be getting passed around, because what happened here is I didn't even bother to print this one because I knew it just looked weird. I'm like, these are my kids, and it looks so strange. And then on Friday, we were like, the printer's open, why don't I try to print it? And it looked kind of weird, as we expected. But then I, for whatever reason, held it up to the light, and all of a sudden I had a photo of my kids in 3D print. So that was really a treat. So be sure you get a bright light behind that one to see it. So yet another approach to creating 3D models. I wanted to create something with our school mascot logo here, the Torrey Pines Falcons, go Falcons, class of '92. And I got this from one of our staff members as a PDF file, and figured out that if I did boundary discretized graphics, I could get a region from that. Because I had noticed something I had never done before, that in Plot 3D, I can tell it to plot all X and Y plot the function over all coordinates that are within the region. So just by creating that region, and I added a quadratic function to it, I could create this falcon shape that kind of lifts off the page. Then applying the same technique, I created my own PDF file of the falcon's text. But now instead of applying a quadratic function, I just wanted it all to be the same height. And then putting them together here gave me this, and I added a cylindrical base and created this final product. And there's actually a handful of them floating around our school right now, and it's kind of fun to see that. Parametric plot 3D. Also, when I did the Falcon, that was with filled surface as well, kind of like I did with the Mount St. Helens. Parametric plot 3D, I used the plot theme thick surface in order to have a surface to print. I've also done that with plot 3D as well. But I would like to be able to control the thickness level. So if any of you out here in the audience have the power to make that happen, this is my plea to you. Unless there's an option I just haven't found in the documentation center, because that happens too. So I'd like to be able to have it be maybe a little bit thicker or a little bit narrower. I'm sure with additional work I could do that. And I created this cup. This is a kind of a low resolution version of it, because the 400 plot points was just going to make the file size here too big. But again, I'm using plot points to adjust the resolution, but that goes back to the whole computational time and file sizes, and like I'm letting things render before I go to bed and then hoping that they look good in the morning kind of thing. Maybe I just need a better computer. Also, the thick surface, I've come across, I don't know if you can see it here, it has like these twists and turns, so it doesn't really have a flat top. and I knew that that would be an issue for 3D printing. So, and I had to use another piece of software to like slice the surface because I wanted the cup to sit flat and have a flat top on the edge. And again, this might be something that's there and I just haven't figured it out, but it would have been nice to have something like clip planes where I could actually clip the surface and cut it off. And in this other program I was using that came with the Windows, I was able to like cut all sorts of things in half and so on, and even do this embossed text that's on the example here too. There's also been a few times when I created like an enclosed parametric plot 3D and I wanted it filled in, and I couldn't figure out how to do that. And maybe it's a matter of making an adjustment in the Simplify 3D, but it seems like there'd be nice if there was a filled surface option sort of with parametric plot 3D as well. So I'd like to share briefly here a couple of projects that my students have done. These were last year projects. Derek and Kathy got really inspired from something they had done in a Science Olympiad that was about wind turbines and turbine blades. So they initially created these manipulates so they could adjust the shape of blades, and then did some other shape adjusting manipulates and analysis graphs. And then they took what they created and did print out 3D. And they did this a few times. They designed their own bracket to hold them together, and they were so excited. They emailed me this photo when they were able to get it all together, and I hope many of you got a chance to get your hands on this. But they actually hooked it up to a device that they had created and spun it around and took measurements, and then they printed more and more and more blades because they wanted each one to have a slightly different adjustment, and then they recorded their data and did analysis. And it was really fun to see what they came up with. And I had only started working with 3D printing in March. And these are my students now presenting this in May. So it didn't take much for the students to get excited and get involved. Another student, Will, he was interested in the Brachistochrone problem and looking to, seeing how a marble would fall on a cycloid shape versus a parabola or a straight line. So he followed basically the same technique that I did to make the falcon head in terms of using discretized graphics and plotting 3D plot over the regions. And he made a cycloid and then turned it into 3 dimensions and did some transformed regions. And then he did this for the parabola and the line, and then kind of added some additional graphics to make this ramp. And it was actually quite large. It was the largest thing we had printed at the time. And immediately I brought it to class, and I brought a few marbles, and the kids sat down, and someone pulled out their phone and did a slow-mo video so we could see what would happen, and testing out the ramps and the result. So it was quite powerful to be able to take this idea that they had talked about in physics, and so get the right shot here so you can see that it actually wins. To take this idea that they had studied about in physics, then use Mathematica to create something, and then we were able to print it and then use it as an actual physical demonstration in class. So that was exciting. Examples of things you could do for other classes. A teacher came to the lunchroom one day. She was with all these little pieces of paper that she had cut out because she was doing these different area problems with her geometry class. And I saw them, and I was in the middle of my 3D printing extravaganza. I said, I can do that. So we custom designed manipulatives that she could use in class. So there's a little tray and different colors, or different tiles and different colors that can demonstrate different shapes and areas. I brought these home to my kids, and even my 3-year-old was just absorbed in what he could create with these manipulatives. Anatomy plot 3D, I think we've seen this hand several times at this conference already, but it was really fun to just take this and just do printout 3D. And it created an STL model that we went ahead and printed. It still sits in my classroom with the supports because we don't believe that we think that if we take the supports off, the bones will start to fall apart because they aren't really joined together that well, but it's certainly interesting to look at. And It just kind of opens up another world of possibilities for what we could do for creating models for other classes. In speaking of biology, we have a class where the students do gel electrophoresis to do genetics work, and the teacher has this little comb that they use in their gel beds to make little holes. And this piece costs between $20 and $30, and she needed to outfit her whole class for them. These were actually done by one of my students who was also taking CAD at the time. So she did this in the CAD program, though it would be easy to see how we could make these in Mathematica. And here we're now producing our materials so that they can run their labs at a much cheaper cost and than what if we would have to purchase them all. We met with the ceramics teacher to learn about her workflow with how she manages one kiln and all these students who want to create their ceramics, because we're dealing with similar issues with the 3D printer. We have 2 3D printers, but now I have my math students, and there's the CAD students who the printers were actually bought for. And how do we start to manage the use of those printers and making sure people get in the queues the right way? So in talking with the ceramics teacher about how she manages her class, we also got inspiration for other things that we can do. And using the same falcon head, we created a custom stamp, and it's actually like filled with clay because they've been using it to make impressions on some of their work. So what does the future hold? One of the things I want to start doing is actually creating kind of lessons for my students. Last year it was all just kind of this big party every day. Hey, look what I made, look what I did. Here, I'll share a file with you. But I wasn't able to do anything systematically. We now have Mathematica and Simplify 3D on computers in my classroom, so every student can have access to this. We also have the printers set up for dual printing. That just happened, like the other teachers set them up over the summer. I haven't had access to the printers over the summer, but I'm excited to go home and start learning about printing with 2 colors, printing with 2 materials, using water-soluble supports. There's all kinds of things we've been thinking about and what we can do. The biggest issue for me is access to the printers. They were purchased for another program within our high school. And right now, that class is all beginning of the school year. Those students haven't gotten to the point where they're printing, but they will, and it'll be really hard for me and my students to get access to them. It's also in the other part of our very large building, and I only got a key to the classroom like last week, so I was always interrupting other classes to get into the room, and there's just been kind of just that access has been a huge challenge for me. I also feel like there's still a lot to learn. Some of these things that were challenges, I'm hoping that maybe some of them are actually not so difficult to overcome, and I want to learn more about when is it best to use Region Plot 3D versus a mesh versus Plot 3D and so on. But it's clearly a fun and engaging way to apply mathematics and Mathematica to the real world. And I always felt that Mathematica let me take what was in my head and really share it with my classes. But now it's like literally bringing that to the next dimension, because we're now able to take these models and the kids get their hands on them, and it's just fun to see how much their learning and understanding is even moving forward by being able to work with the 3D models. Not only just being able to have them in class, but even those students who invest the time and interest into creating them themselves and all that they learn along with that. So thank you very much. That's my presentation.